is. Okay, about 30%. So I thought we'd start with understanding what a GMO is, the term GMO, how it's been manipulated in the media and by scientists, and then I'm going to talk to you about the dangers of it based on research that I've actually done, scientific research. A little bit of background on myself. You know, I grew up in India originally, it's the city of Bombay, which is basically New York on steroids. But I also grew up in a very small village where my grandparents were farmers. My grandmother was a village healer. She could observe your face, for example, predict what was going on in your body using an Indian system of diagnostics called Samudrika Lakshanam. It means face analysis. You know, and now in the West, people are starting to do AI, then it becomes acceptable. But when a woman in a small village with tattoos all over her arms does this, it's seen as woo-woo medicine, right? But that's the way things go. So I was motivated as a young kid to understand how my grandmother with no degrees was able to do this. She would observe people's face. On weekends, probably 30, 40 people would be lined up at her home. And she would figure out how to heal them using mixtures of combinations of yoga, herbs, what we today would call personalized medicine. So Richard would get something very different than Alan, for example, right? Precision medicine, the right food or the right herbs for the right person at the right time. So that's what I grew up in. That's my background. When I came to the United States, went through the public school system, went to MIT. As I mentioned, I did a number of degrees, always interested in engineering systems, and got very, very dissatisfied that the Western system of medicine was very reductionist. What reductionism means is that if someone comes into your office in medicine and they have a headache, the doctor may send them to 5 different specialists, right? An endocrinologist, a psychologist, and go down the list, right? It's not about understanding the body as a whole or as a system. Now, something changed, though, however, around between 1993 and 2003. 1993 is when the Human Genome Project started, and the idea was, could we use science to understand our DNA? And the idea was that if you had a worm, you know, a lowly, quote-unquote, a lowly worm, we knew it had around 20,000 genes. By the way, genes are the substances within the nucleus of a cell which determine what proteins get created, okay, what molecules in those proteins interact to create different cellular functions. So the notion since the 1950s was by Watson and Crick, the guys who sort of discovered DNA. A woman actually did most of the work. She didn't get all the credit, as some of you may know. But anyway, the notion was if you have this gene, then you're definitely going to get this problem, or this characteristic. So if you have the gene for blue eyes, you're definitely going to get blue eyes. If you have the gene for diabetes, you're definitely going to get diabetes, right? This is called the Watson-Crick central dogma theory, which means genes drive everything. It's like a unidirectional model. Everyone following me? Mm-hmm. Okay. So that was called the central dogma theory of Watson and Crick. And in 1993, people said, let's figure out how many genes a human being has. We knew a worm had 20,000 genes. So what was these scientists' estimates? Do you know what, in 1993, you know how many genes they estimated? 100,000? About 100,000 genes. At some point it was 500,000. So think about how these scientists were thinking. Oh, we as a human being are more complex than a worm, therefore we must have more genes, mean more parts. You see the problem with this thinking, we'll come back to, is that the sum of the parts is greater than the whole, right? So the notion is that, oh, we're more complex, we must have more parts. So 1993, around, the Genome Project starts, and you start watching the progress. You know, 5 years later, they're not finding 500,000, 100,000 genes, so they reduce it to 80,000. Then a few years later, it goes down to 70,000. Anyway, by 2003, you know what we found when the Genome Project ended? We have about 20,000 genes. We have the same number of genes as a worm. Pretty ironic, right? I don't know how many of you knew that. So now it completely threw biology on its head. Because the old model was, oh, these people are smart because they must have smart genes, right? And these people are stupid because they have stupid genes. And remember, this can lead to all sorts of very interesting profiling of people, subjugation of people. You follow what I'm saying? Mm-hmm. So when that occurred, it created a new field called epigenetics. And what epigenetics said, it's not a one-way model. You have a gene, and you create a protein which creates this cellular function. There's actually feedback. Turns out that the genes that we have can be turned on and off. So there's a lot more complexity. What can turn off genes? Well, what you eat, the environmental pressures you're under, right? The pollution, how you treat the whole system. Because genes, it turns out, if we want to look at it a different way, anyone play piano here? Any piano players? Wow. Okay, well, Rob plays piano. But if you look at piano, piano has a fixed number of keys, right? Yep. How many songs can you play? Infinite. Well, that's how genes are. There's maybe a fixed set of genes, but you actually can play infinite choreographies, which are the proteins that get created and how they interact. You following me? So what are those? In a piano, you're using your fingers. Well, these fingers are environmental factors, right? What we think potentially, many, many things which can turn off and turn on genes. So that became the field called systems biology. So, I had gone to MIT in 81, graduated with a double E degree in 85, 86, then went and started one company, came back to MIT, did a master's at the Media Lab in graphic design and computer visualization, another master's in mechanical engineering, went off, started a few more companies, and I was literally walking down MIT, and I met my old advisor. He goes, Shiva, you got to come back to MIT. This is 2003. There's this new field called systems biology. You've always wanted to take a systems approach to the body. He said, you should come back, and you should use your experience in computing. A lot of you may know this is not the Al Gore story. I actually invented the first email system when I was a 14-year-old kid. It's a true story. I took the old inter-office mail system, inbox, outbox, folders, and converted that to the electronic version as a 14-year-old kid, called it email, got the first U.S. copyright for it. It's in the Smithsonian. So I knew how to build systems. So Professor Forbes Dewey invited me back, and starting in 2003, I looked at this problem, and the idea was, could you mathematically model the whole human cell? The National Science Foundation said, hey, if you could model all the reactions in a human cell, you could technically predict what was going to happen, right? Now this was like what they called a grand challenge problem, like landing on the moon. So I came back to MIT and I took not a biology approach or a computer science approach, I took what I called an engineering systems approach. So this is how science works today. Let's assume everyone in this room today is doing research on cancer, right? So let's say each one of you runs your own lab. So there's 100 different labs being run. Each one of you are the lab directors. So when you look at scientific research, what you find is none of you guys collaborate. Do you know that? Mm-hmm. Why? Because Richard gets funding, and NIH funding, and he's just a junior faculty. He's got 7 years to get tenure. So what does Richard do? He takes his funding, he gets his graduate students, he generates his data, and he hoards it. Because he's got to publish so many papers, which have to get cited. Okay? And Alan would do the same thing. Richard does the same thing. Because they're all about owning a narrative and getting it published. Get it? Mm-hmm. Now, the way you get tenure in science is Richard publishes a paper, and everyone else has got to say, well, that's a great paper. So he has to basically suck up to every one of you. He does. Mm-hmm. It's a big suck-up game. And then you cite his paper, and then he gets tenure. It's a complete racket. It really is. Mm-hmm. So that's how science gets done. So part of this, so what happens is all these papers are being published, right? So if you take a field like pancreatic cancer, there's probably 100,000 papers out there, each talking about little pieces of the puzzle, like the old blind man. You know the story of Buddha, who tells the story of the king who invites the 6 blind men, and he gives them each a piece of the elephant to touch, and each one has their view. The guy who's touching the tail thinks it's a brush. The guy who's touching the tusk thinks it's a spear. The guy who's touching the legs thinks it's a wall. And if they were to put it all together, you'd end up with nothing that looks like the elephant. Well, that's how science fundamentally works. People work in their little silos, and if they were to put something together, they would never really understand what's really going on. So the idea was, could you take all your research, connect it together, because each one of you may be doing some research on a particular aspect of cancer, you're understanding the chemical reactions, Dr. Kishore is doing something else, Frank there is doing something else. But if you could have a technology which you could read the literature, extract out objectively the chemical reactions, right, because they're a piece of the puzzle, mathematically model them, and then connect them together. Pretty big thing, right? Mm-hmm. Well, to me, when I looked at this problem, I said, wow, this is no different than people with an airplane. The little pathways, which are called molecular pathways, are like little parts of a plane. And so the short of the story is I spent 5 years at MIT for my PhD building a powerful technology to be able to do this. So if email was the electronic version of the interoffice mail system, Cytosolve, this technology I created, was the electronic version of the molecular communication system. So what we were able to do was we could go into a field, read the literature. Remember, albeit it's not perfect, but we created a framework to model very complex things. How did we prove it? Well, we took on pancreatic cancer. We took the known papers in that field, modeled it, went through all the drugs that have been used, which is known as a gold standard. But a lot of people are recognizing that herbs, nutraceuticals, these things may be valuable. Diet. But the problem is they don't know how to model that, right? Because drug development today occurs in the following way. If Richard is a scientist, he thinks this drug works, he raises a $50 million, he does tests in a test tube, then he kills a bunch of animals for 5 years. If he makes it past that, then he gets to file a agreement with the FDA where they let him test on humans. That takes 15 years, $5 billion, and the stuff that comes out has a lot of side effects. So in pancreatic cancer, there's one real drug called gemcitabine. But people are recognizing maybe you need to combine drugs, right, to lower the toxicity. So using this technology to validate it, we went through all the known drugs for cancer, around 200 drugs. Without killing any animals, we found a combination which did better than gemcitabine, and then we applied to the FDA. We got allowance in a record 11 months. And then we spun it out with MD Anderson. So this sort of showed that, wow, powerful technology. And since then, we've spun out 7 different companies. We just, in a few months, we're going to be modeling Alzheimer's. Oh, yeah. It'll be done. So we're going to be able to test what ingredients work. Periodontal disease, prostate cancer. We're going down the list. Right now, it takes 15 years. We're going to drive this down without the need to kill animals. That's what's. So anyway, that was going on. And I had built that by 2007. And so I went to India, by the way, in a Fulbright, interconnected Eastern and Western medicine. I took a little time off in 2007 to 8. When I got back, I was walking down MIT one day, so around 2013, and I see the MIT Technology Review. We don't have a copy here, but on the front page of it, it says, buy fresh, buy GMOs. Yeah, so I was saying, what is this? And I didn't know a lot about GMOs. So now here, I've been in and out of MIT for 33 years, know the institution pretty well, have my degrees, have taught at MIT, and I see this article, and it didn't look like a scientific article. It looked like an advertisement for Monsanto. And it really pissed me off. I'd been on the front page of that magazine for starting another company, so I knew the editors. And I went, as you go through this article, the argument that they make is the poor people in Africa. It's always the people in Africa that need us, right? Or the poor people in India, right? They're poor. They don't have enough food. We need to produce more food, right? By the way, this is what Bill Gates and Bono of U2 have been promoting. Complete full of shit, okay? It's a pile of shit, in fact. And I want to use those words to let you know that Bill Gates and Bono have been promoting this model through the Gates Foundation. The reason it's a pile of dung is that the reality is we produce a lot of food, in fact. We produce enough food for every person to have 6 cheeseburgers. It's all industrialized food, okay? We actually produce quite a bit of food. But what we don't produce is food, organic food, healthy food, which was what Americans want. So when you look at this article, the argument that MIT or the writers were making was that, oh, we need genetically engineered food because the soil of these countries is not producing enough food, so we need to give them, genetically engineered crops, okay? Complete nonsense. So let me tell you what a genetically engineered crop is. How do we breed things in nature? It's sexual production, right? Mm-hmm. Right, so if you have pollen, the bees goes, it's actually what's called sexual reproduction. Male and female meet, right? Animal, that's called sexual reproduction, right? What occurs in sexual reproduction? You have an egg, in the case of humans, right? A sperm hits it, half of the DNA from here, half of the DNA, they mix together. It can only occur, it's a sexual activity, right? Well, genetic engineering is quite different. It occurs in a test tube, in a lab. And it occurs where you can take the gene of one organism and you can put it into a gene of another organism. Give you by way of example. You have a salmon, which is very resilient to cold, right? Their skin. You take that gene and you put it into a tomato. You're never going to see a salmon having sex with a tomato, right? It doesn't occur in nature, right? At least I haven't seen it.
Won't be fertile.
Right, won't be fertile. But that's, so what happened is the term genetically engineered foods was called GMOs in Europe. When it came to America, the American agrobiotech was very, very clever. They started conflating, which means confusing, GMOs with plant breeding. Now you got to follow me on this. They said, oh, everything is genetically modified in nature. Right. The Incas grew rice. They did this, right? And the New York Times, which is a completely nonsensical newspaper, now they don't do any research. When I was in the 70s, they actually used to do research. So they started repeating this. So if you read the New York Times articles, they were saying, oh, what's the big deal with GMOs? They're no different than plant breeding. You know, people have been doing mating between this cow and this cow type. And well, that's sexual reproduction. This is and they glossed over that because they confused Americans to think, oh, that's also GMOs. You following me? Mm-hmm. Very clever. So you guys understand that's how clever and that was a PR machine of a company called Monsanto and the agrobiotech industry. So in genetic engineering, again, what I'm saying is they take an organism and they take the characteristics of another organism and they stick it in here to get this characteristic. Okay? Got it? So now so let's say me and Richard want to we want to create a GMO company for GMO blueberry. Okay? In fact, there's a new apple, I don't know if you've seen it. Yeah. You slice it up and it doesn't brown. Have you guys seen it? Yeah. So you can package it so people save time cutting. Okay. That's what they created. So how did that company, let's follow this, it just came out. How did that company get that GMO apple out to the market? Any thoughts?
Crossbreed with a lemon.
Well, yeah, but they did. But how did they get approval to distribute that?
They probably used the junk science. They probably used the junk science that it was just.
Yeah, but how did they get it allowed so they could get it on the shelf? What's that?
They had connections to big corporations.
They had connection to big corporations?
Generally regarded safe.
Generally regarded safe? Okay, let me tell you what they did. So as I started researching this, it turns out that in 1976, Gerald Ford, who's the President of the United States, he issued a guideline called substantial equivalence. Substantial equivalence. Let me tell you where this came from. You know, the U.S. government wanted, or claims they wanted to support innovation. So if, again, Richard and I, by way of example, created a stethoscope, for medical device, and it took us 7 years to get that allowed by the FDA. Medical devices need FDA approval. Okay, so the FDA now approves this medical device. Took 7 years, and me and Richard are starting our company. We're out there, we're selling stethoscopes. One day, Richard says, you know what? The white stethoscope color is not working. We got to make them bright pink, you know? The doctors like bright pink stethoscopes. Well, by the old law, you would have had to go through another 7 years of approval. All I did was a little itsy weeny teeny weeny change, right? Change the color.
510K.
So, what's that?
510K.
510K, exactly. So what the substantial equivalence guideline, Ford said was, look, if someone makes a small itsy weeny change, the manufacturer, in this case Richard and I, all we have to tell the government is we choose our characteristics of equivalence. So here is a white stethoscope. It weighs this much. For example, we used weight as a criteria. If we used, you know, the size of it, whatever criteria we want, we said, you know what? Based on these three criteria, the new one's the same. Look, it's the same height, same weight. Then we present that to the FDA, and if they will issue us a safety consultation letter. They don't approve it, and they can fast track it. Got it? So you didn't have to. So you basically self-report that it's substantially equivalent. Anyway, that was good for medical devices. So that guideline was passed and put into place. Now move forward over to 2000. When did Obama come into power? 2000. 2008, right? So when Obama comes in, now you have GMOs coming. He puts in position a guy to be the deputy director of food at the FDA. Anyone know who he put in power? This is Obama.
Taylor?
Michael Taylor, who was a former executive vice president of science policy at Monsanto. Okay? Obama, okay? Remember, they like to put people who look a certain way to confuse everyone else that they're helping poor people and minorities. Okay, that's Obama. So they put him in power. So Obama put Michael Taylor in power. So Michael Taylor, so people are starting to produce genetically engineered foods. Well, how do we decide these are safe? So what does Michael Taylor say? He goes, oh, we're going to use that 1976 policy of substantial equivalence. So remember, medical devices are nowhere as complex as a genetic organism. So what do? They say basically when Richard and I want to make our blueberry company, we simply tell the FDA, hey, we looked at 5 criteria, the GMO blueberry and the non-GMO blueberry, and they're all about the same. And we could choose whatever criteria we want, amount of water, amount of the color, the weight, whatever we want. So we simply submit to the FDA, write to them, not even data, that we did the testing, be happy. The FDA issues me and Richard a safety consultation letter. Thank you very much that you have told us that you've done this. That's it. With that, we sort of go out to market. Got it?
Wow.
A lot of people do not know this, and this is never discussed because most journalists haven't even gone down and looked at this.
There's no pre-market authorization? Or
Nope,
Okay.
nope. And you can go onto the FDA website. They have 140 at the time safety consultation letters.
That was made to kind of decrease healthcare costs too, because they would create like a generic for a drug that had gone through
Right.
a phase of having a copyright kind of thing, and then you'd be able to put out these generics for less money, and it was intended for that reason.
That's what it is.
And
But
it's now being used and manipulated.
right. So if you think about what you just said, you know, I don't care for Big Pharma, but Big Pharma at least is under a little more transparency in the sense that all their clinical trials go up on clinicaltrials.gov. Everything's published. So every test they did in phase 1, phase 2, any one of us can go see, for example, if you look at any drug like Lipitor, you can see all the trials. But where's that similar thing for the genetically engineered blueberry that he and I just got approved for, or if we did, okay? It doesn't exist. So when I started looking at this, I said, well, if you look at, we took soybeans. The reason we took soybeans is 97% of the soybeans in America are genetically engineered. 97%, okay? So we said, okay, so how do we compare the GMO soy with the non-GMO soy? How do you make, right, what are the criteria? And if you look at the criteria they use, none of them make sense. So, well, how do you look at the criteria? What is a criteria that makes a male different than a female? Well, we know there's the XY chromosome, right?
Right.
So if you look at, you know, all the biology come down to a particular criteria. So we needed to figure out what that criteria was. We wanted to do objective. In my first paper I wrote, I said, look, I'm not pro-GMO or anti-GMO. I just want to look at this. So the first thing we did was, we said, okay, how do plants work? Plants are like little machines. So how do plants work? Well, it turns out every plant in the universe, every bacteria, and every fungi has a machinery. Anyone a mechanic here? Anyone work with engines, motors? Okay. Well, to think about it simply, a plant has an engine. What does a plant do? It does photosynthesis. It takes sunlight, right? And it brings together carbon. It brings carbon together to do what's called carbon sequestration, and that's how it works, okay? Anyway, the bottom line is every plant has a metabolic process, like we have digestion. Well, when you digest something, what do? You create waste, right? And it gets removed. Okay, a plant has a similar mechanism called C1 metabolism. I'm going to teach you some quick biology. I'll be simple. That C1 metabolism process has 3 big components which work together like an engine. Methionine synthesis, methylation, and formaldehyde detoxification. Okay, they work like, think about 3 big blocks if I were to draw here. And they work like an engine. So plants actually create formaldehyde. They do. It's a byproduct of their metabolic process. But they chew it up using a very, very important antioxidant called glutathione. When you get home, you can look up glutathione. It's called the master antioxidant. There are certain foods like raw milk, whey, which create glutathione. As you age, glutathione level drops. Many people consider it the anti-aging nutrient, but it's an antioxidant. When you're under stress, glutathione kicks in, okay? Plants have it, we all have it. So in this process called C1 metabolism, this happens. So what did we do? We knew if we published one paper exposing this, we'd be trashed. So what we did was, first we did a very systematic study. We read, using cytosol, every paper written on C1 metabolism. We organized it, and we said, here's the literature, and we published that in the, I think, the American Journal of Plant Sciences, an open access journal, which means we don't have to, it's not like a peers review it, which is what they want to do so they can control it. We published that very quietly, got that published. Then a few months later, we said, okay, now we understand all the papers, let's mathematically model it. We modeled it using our engine. And what we found was, when plants, the normal plant, it creates formaldehyde, but then it detoxifies it. So the curve looks like this. Got it?
Yeah.
And glutathione is steady state, which means it stays at a beautiful level. It just sort of hums along, because glutathione doesn't get depleted. Got it?
Is it catalyst?
It's a, you can think of that as a catalyst, meaning it's glutathione helps detoxify. So in the normal plants, glutathione is steady state. Plants create formaldehyde and are detoxing. Got it? So that was paper number 2. We published that in the Journal of Agricultural Sciences. Did that. Then the third paper we did was we said, what happens when a plant undergoes stress? Like we undergo stress, right? You had a hard day, pollution. These things deplete your glutathione levels. It's called oxidative stress. So what we did was we then looked at the literature and found out under what conditions do a plant undergoes oxidative stress, and we connected that model, and we found out was something fascinating. When a plant undergoes drought or pollution conditions, it says, oh my God, I'm being attacked, so it uses up its glutathione. So glutathione levels drop, and guess what happens?
Or formaldehyde.
Formaldehyde accumulates. Now, in the natural world, this doesn't occur forever, right? You get a little drought, and then plants are resilient, then they can, so it may go down and may come back up. That's called, and we modeled that and we showed that. Published that also in the American Journal of Plant Sciences, paper number 3. No one said anything. Paper number 4, we said, okay, what now happens when Monsanto soy is the organic soy, what Monsanto did was they created a version called Roundup Ready Soy, right? Roundup is Monsanto's pesticide. As I mentioned earlier, they created Roundup Soy was because they were selling soy to farmers, let's say like Alan. He's planting soy, and he's using their herbicide, glyphosate, and a lot of his soy plants are dying. They said, you know what, Alan, I got a new soy for you. It's genetically engineered. How did they do it? They took a bacterium, and they inserted it into the soy, and they created what they called their own soy plant, which doesn't get affected by their own herbicide. So now Alan's hooked on their pesticide, herbicide, and he's got to buy their seed. Got it?
Yeah.
Okay. So now Monsanto, when they got this approved, they said, no, don't worry. This soy plant is no different than the GMO. How? Through substantial equivalence, by choosing their own self-reporting criteria. 97% of soy. So we said, okay, so we found papers showing that when the genetic engineering of soy takes place, 5 or 6 different molecules vary significantly. So we took that data, remember we'd already published these 3 papers, modeled it, and we said, what happens when you vary those in this very complex molecular system? Guess what we see? We see the plant thinks it's under oxidative stress. So the plant actually lowers its glutathione, and it accumulates formaldehyde. When we published that, we were pummeled by the experts, the Monsanto shills in academia. One of them being a guy called Kevin Folta, who attacked me saying he didn't invent email. That's how, nothing substantive, none of our papers, and then proceeded to say how he's an independent scientist. He doesn't get any funding from Monsanto. This is going on. A nonprofit group in the West Coast called U.S. Right to Know filed a FOIA, Freedom of Information Act, on the University of Florida, which is a public school where he works. 4,000 emails come out. Now you got to remember, up until then, the New York Times, everyone's saying, oh, no big deal. So one of the emails, and it's fascinating to see what she put up on our website. It literally is a letter, on Monsanto's letterhead to Folta, giving him $25K to be their spokesman. Okay? That's what was taking place. So then what we did was we got very lucky. We did a fifth paper. We found a research group in London who had actually grown the soy plant. These guys were saying, oh, this is just a mathematical model. It doesn't mean anything. Well, a group in London had actually grown the soy plant, and they too found that the organic soy had 250% higher glutathione levels than the inorganic soy, and that brought it all together. So the reason I'm sharing this with you is that the real dangers of GMOs is that there are no safety assessment standards. You follow? It's all, even a drug goes through 15 years of testing, and they still have side effects. These guys have manipulated their way. Henry Kissinger said something interesting. He said, if you want to control a country, control oil, but if you want to control a people, control their soil. All right? That's what we're witnessing. And the Gates Foundation are not a nice bunch of people. They have their self-interest, which is basically to own as much land as they can in Africa.
Right.
That's what they're really doing. And what we're seeing right now is that the politicians do not, as I said, Bernie Sanders took $18K from Monsanto. Okay? Not so nice guy. They all put up a good front. Elizabeth Warren supported the Monsanto Protection Act. Right? What I learned as a kid when I came to the United States is there's the establishment. People want to keep things the way they are. There are the change agents, everyday people, like everyone in this room, who want to fight for a better day. And then there's something even more insidious called the not-so-obvious establishment. These are the people who act like they want to help you, like they're your fighters. They speak a good game, but when you actually look at what they do and the rubber meets the road, they're actually more insidious than the establishment. Elizabeth Warren is one of them. In many ways, sorry to say, Bernie's one of them. Okay? At the end of the day, he supported Hillary Clinton. Elizabeth Warren had a chance. She supported the Monsanto Protection Act. She screwed over the labeling bill, which myself, Neil Young, and Governor Schumer were up in Vermont, which was to give state rights. They brought it back to the federal level, and they screwed it. They made it, the avert GMO labeling bill, it clearly says GMOs. What they did was, you need a smartphone scanner. No one has smartphone scanners to do that. So they don't have clear GMO labeling. That's brought to you by Elizabeth Warren, the not-so-obvious establishment. So what's really fascinating with food is it's where the rubber meets the road, because that's where you can really figure out what's going on politically. 80% of Americans want organic food. People want access to better food. And the reality is a few companies control that access. And they are part of what I call the military-industrial complex. If you unravel where Monsanto came from, they came from creating Agent Orange, right? Today's an important day, as everyone knows. It's Veterans Day. A lot of veterans gave up their lives. 50,000 tons of Agent Orange were dumped in Vietnam, affected a lot of veterans as well as a lot of other people. And I think it's really a point, and the fact that there's a health expo going over there is interesting. By the way, what's unfortunate is a health expo wouldn't even allow us to distribute our cards against GMOs. So someone should go talk to them. It's bizarre. It's completely bizarre. It's absolutely insane. Everyone should be hearing this talk. So anyway, so we have an opportunity, though. The opportunity is, I think the key takeaway is, there are no safety assessment standards for GMOs. This is not a left issue. It's not a right issue. It's not a Democrat issue. It's not a Republican issue. It's an issue that affects every person in this room. Because it's really about you, right? Thank you.
Monsanto's all about selling soy as a health product, and it's
Right.
really fermented soy. That's a product.
Fermented organic soy.
Yeah.
In traditional cultures, one of the things they knew was seeds, particularly seeds and grains, were not supposed to be eaten directly because they have phytic acid, which leaches. The phytates bind to minerals and leaches. That's why a lot of vegetarians don't look that healthy. They don't, because they're eating. In traditional cultures, what they learned is you should always soak your seeds, germinate them, or slightly roast them, so you destroy the phytates, and then you consume it. Right? So what he said was
Soy milk and
so,
it's Monsanto's behind this.
Exactly.
Another head of their hydra.
Yeah, I think what David's bringing up is really important. These guys are so insidious, man. They figure out how to promote things as a health thing. No, they do.
Yeah, but they also went a step further and started putting the soy oils and all of that into pretty much
Everything.
Single food.
As an
Any
ingredient everywhere.
restaurant Pretty much has soy in it now.
Right.
So they went a step further. They not only messed with the food and made sure the farmers had to use their seeds, they actually put it into every single product that you would not even really realize you're consuming unless you become allergic to it, which is now what's happening.
Yeah. The important, let me tell you, so all is not lost. In fact, there's a huge opportunity. And I'll tell you, it's a business opportunity, it's an entrepreneurial opportunity, it's an opportunity for us to take back our health, is this. When you look at the economics of this, the software internet industry is now a $400 billion industry, which we think is huge. But the food industry is a $4.7 trillion industry. Trillion. And the biggest, if anyone wants to make good money here, go start an organic farm. There's not enough supply. Seriously. It's 30% year-over-year growth. Go start cool organic restaurants. So one of the things that's the opportunity is, the demand is there. The unfortunate thing is we got to watch for the centralization of this. Amazon's buying of Whole Foods needs to be watched very carefully because they want to industrialize even organic food. What I mean by that is you can have something quote-unquote organic picked in Turkey or a green banana thrown in a trailer. By the time it comes here, it's not the same food. There's real food brings down to the nature of why we need things to be decentralized. It has to be local. You see, when I go to India in a village, I don't know if you've ever, or to Italy, you eat food, it smells really good. You don't smell a lot of the food here anymore. I don't know if you know that. Because it's been picked way before, and it's sitting there, and most people live in what's called allostasis, which is a state of constant unhealth. Right? This is what I mean. Both parties, if you see these t-shirts, live on war and sickness. So they have the agrobiotech, which drives you into sickness, makes you think you're supposed to feel all screwed up all the time, and then you need to take this and this and this to feel good. A clear indication of this is Monsanto and Bayer. Monsanto was getting so hard, guess what they did? They sold themselves to Bayer, the children's aspirin company. So on the one hand, Monsanto now creates, to your point, soy. What we've shown is soy has Roundup in it. Well, ultra-low levels of Roundup, glyphosate, the research just came out, published in Nature. People got it in there, which was a pretty amazing job. Ultra-low levels cause fatty liver disease, which is NASH and obesity. They found parts per billion, but ultra-low levels in women's tampons. Okay? So that's what we're dealing with. Now, none of these politicians are going to say anything because they're funded by both sides.
And aspirin is essentially organic, so they sort of covered themselves.
They covered themselves in that. So I think we have a huge opportunity to address this issue head on. It's not a left or right issue.
Have you
Dave?
estimated what this costs the healthcare system?
It's probably trillions.
You could, I mean, this is not a new GMOs and the problem with our industrialization of our food since the 60s. And we have an old saying in New England, an ounce of prevention is worth a pound of cure, but well, how much is the cost? I mean, estimated, is there any good literature?
Well, let's do a back of envelope, okay? Go look at the top 35 drugs that are created. The number one drug is lung cancer, okay? We know these things that they spray cause all sorts of COPD and lung cancer disease. I just finished a movie I think I shared with you which Pierce Brosnan produced and his wife. They live on the island of Kauai. It's called Poisoning Paradise. It clearly shows what it's done. I mean, do you know Hawaii? Hawaii, anyone been to Hawaii?
Yeah.
Beautiful land, right? Grows. You drop anything, it grows. Do you know that they import 97% of their food?
Wow.
They're using the island of Kauai as a test field for these agrobiotech companies. So they've destroyed their agriculture and they import in stuff. It's unbelievable what's taking place. And it's taking place because these career politicians get paid off and they don't do anything. And what you're going to see is it's going to affect our youth. I see it. A friend of mine used to run a great health food store on Mechanic Street. He goes, Shiva, I used to help so many people. But you know what? I started seeing genetic abnormalities at a deep level because it's stuff they're consuming all the time. So the issue of real food is not like a hippie issue anymore. It's not like a woo-woo medicine. It's an issue that affects everyone. Thank you. Yeah.
Just a question. You say you're going to take on Monsanto. What is your plan? How do you...
Yeah, great question. Yeah, so the question is, how do we take on Monsanto? It's not only Monsanto, right? It's the complex of the fact that when we go back to health, right, the first thing to take people on is to use this platform. These people were given, these politicians were supposed to represent us. They don't use the platform to represent us. Forget about passing a bill. Let's forget that, okay? Let's forget that for a second. But they should be using that platform to speak on your behalf, right? That's what I'm going to do. So first thing is, let's start educating people. What is Monsanto? What is a genetically engineered food? Where this stuff comes from, like we're doing right here. That's what they should be doing. They don't do that. They, in fact, suppress that. So what do we do against Monsanto? The first thing is to start supporting policies where we can unleash local agriculture.
Introduce a bill.
What's that?
Introduce a bill.
You can, definitely. But I'm saying,
I'm going to introduce a bill that will hold blah, blah, blah.
yeah, right. But what I'm saying is the first thing is educate people. But as a part of that, we need to build a grounds-up movement where people start demanding at all the local levels. Wait a minute, Dr. Shiva, MIT-trained guy, he could have sat at MIT and gotten all the awards, and he's won. Why is he saying this? So first is education and creating an uprising among people into their school boards, into their local communities, demanding that we have locally grown food and creating the public policy to support that and the infrastructure to support that. Yep.
Why is organic food so expensive? Is it strictly a supply and demand thing, or are other strings being pulled?
Oh yeah,
behind the scenes?
it's a great question.
Prices.
Yeah. So he asked, why is organic? So do you know where 18% of the U.S. GDP comes from? It comes from logistics. It's a thing that no one learns in America. And you know, in Europe, when you're in grade school, you learn logistics. Logistics is how do you get everything in this room, probably came from China, okay?